Hey guys, welcome back to Getting the Blinky tutorial as part of KiCad series of contextual electronics. This section's about finishing up the schematic that we started last time. Last time we created a schematic symbol for the 7555 timer, which is the main component in the circuit that we're building here. So let's take a look over at the screen and start finishing up the schematic. So here we go back to the launcher. I'm going to click this. You see I still have my screen locked to the left side. I had also rotated this component. If you remember, if you looked at the old video, actually it finished like this. So do make sure that you have the pins 7, 6, 2 on the left side here. Otherwise it probably won't make sense. Okay, so we're also going to pull up that schematic that we were using last time. There we go. And now what we're going to do is we're going to hit the A key and then put in some of these other components. So we have 3 resistors, we have a capacitor, and an LED. Resistor LED is doing the flashing, resistor doing current limiting, and then these 3 are actually just kind of setting up the timing. So what we need to do is first hit A, and then we see if I type in R, I can, if I type in R, it already has it pulled up here. And I'm going to drop that component here. Now if I want to copy this same component, I mouse over, I hit C, I choose the component itself, and you see that there's a second component now. Cool. Hit escape again, get back just to the main mouse type here. I'm going to hit A, type in C for capacitor, select that, hit OK, and then drop this component. We need one other resistor here, so I'm going to once again mouse over the resistor, hit C, select the component, and then move it over here. And now I'm going to hit A one more time, and then type in LED. See, there's a default component for this, or a default symbol, and we will use that. You see it does match pretty much what we have there. Okay, great. So now what do we want to do? Now we want to hook this thing up so it actually looks like how we expect it to look. I'm going to just move these up a little bit here. We want the 7 to basically kind of go between these 2 components here. Once again, I'm just hitting the M key. It's a hotkey to do that. Now if I want to start drawing a trace, what I do is I can click over here on the green line, which is place a wire, or I can hit W, which is what I normally do, to start drawing a wire. Now you'll see I did that right over top of this node here, and I am just scrolling in using the mouse wheel. So what I'm going to do is go to this point, take it up here, and click on top of the node, and you should see that circle disappear. Same thing down here. I could start another line from that corner, go to the circle, and now you see not only does this circle disappear, a solid circle appears, which is called a junction, and that indicates that those 2 lines are connected. If you don't have a junction, you don't have a connection, so that is very important there. Okay, so now I'm going to connect these 2 together. Oh, that didn't work. Control Z to undo. Looks like that's actually it's having trouble finding that node there. Interesting. Okay. Well, what I'm going to do is actually just change the grid just to make it a little bit smaller. I believe we created that on 25 mil grid. So if we right click, go to grid select, this changes the size. You see it's in millimeters, or we can do it in mils. If you switch it to inches up here on the upper left, then it will show up just as default mils. And there we go. So 25 mils is how we created this thing. Now it should work. So once again, if I hit W to draw a wire, now I can connect these 2 together. So now those are connected, and then we also want to connect them to this resistor and capacitor pair. We should have a junction created here. That's good. And then I'm going to move. Oh, I think that's actually good. Yeah, that's good. Okay, good. So now we have those all connected. What I also want to do now is I'm going to draw another one from the bottom of the capacitor. I'm going to draw it over to this point. And what I'm going to do is actually end the wire here by double clicking. And you see it leaves a similar square, empty square there, showing that it's not connected. And that's kind of how you can tell. Now we're going to make these connected. The circle disappears, the square disappears. Okay, and there we go. Another junction created. And then finally, over to the LED. We're going to hook the LED into the resistor, and then the resistor into the output. Very good. A couple more here. I'm going to create the final connection up to here. Zoom in, close that one off, and then I'm going to close this one off. Awesome. All right, now I'm going to do is label this top one to be not 9 volts. We're going to just call it VCC, or sorry, VDD, which is going to match pin 8 there. I hit escape. I'm going to hit L for label, and then VDD, and then I'm going to apply it right to the top up here. And you see that again, there's that open square. If I apply it to the line, it should disappear. So now this upper line is, this upper wire is VDD. Same thing down here. Now I'm going to actually apply not 0 volts. I'm actually going to call this ground. In order to bring in a ground symbol, what we're going to do is we're going to hit, we can either do one of two things. We could hit this symbol here, the power port, or we can hit P, and then it pulls up another menu to load up here. And now you see there's a wide range of different rail voltages and grounds that we can pick. I'm just going to pick the default GND for ground. And now this also will connect this node to the ground node effectively. So now this whole node is now labeled GND, even though we didn't explicitly label it with by hitting L and then typing in GND. So now we have VDD and GND. What we can do now is we can go and we can enter battery. So there we go. We got a battery device. And what we'll do from here is we're going to assign, we won't actually connect it. I just want to show you what it is when you have nodes. So what we'll do is we're going to have a W for a wire, and I'm just going to create just a top and a bottom wire here. I'm going to go copy this ground symbol, and then I'm going to label the top of this battery to be the same as VDD. So hit L again, VDD. And now what I'm going to do is actually rotate this around, so now that it lines up square over square. And now, even though it's not physically showing as it being connected, because it has the same name, the program interprets it as this line being connected to all of these lines up that are labeled VDD. And that's a pretty important concept. That's called a net, and that's kind of how a lot of schematics work. So we have a battery, we have power and ground. This VDD represents power and ground. We have the 7555 hooked up. We have our resistors, we have our capacitors, we have our LED. Now what we want to do is actually apply some values here. So what I'm going to do is zoom in. Now you can do this one of two ways. You can right click, go to component, three ways actually. Edit component and then component value. That's one way. We can mouse over the center and edit the value here. Or what I always do is I just mouse over and hit V, and then I match whatever the value I want it to be here. So I'm going to type in 1K. This one down here is 470K. Sorry, V, or 70K. If we just mouse, that view that you just saw there is if I mouse over and hit E, that's just the value here. You can see that we can go and edit it like this as well. You click on it up here, you can go edit it, the field value right here. So we can make that something else if you wanted to as well. And that's how you add other information. So if you wanted to add the voltage rating or something like that. Okay, so same thing here. We can edit this one. So we're going to put it as 1U for 1 microfarad. It's actually a mu, but we're going to write U. So there we go. And then over here, this is going to be 1K. Again, I just moused over and hit V. And then finally, this one we're just going to call, well, it's already called LED and D1, so this will actually assign D1 when we annotate the schematic, which is the next thing we'll do. So we have our battery. I'll move the battery a little bit closer actually, and we can now make this thing full screen. Okay, so we have our battery, we have our components, our passives, and we have our active component here. Very good. So I'm going to save. Next thing up is I'm going to annotate the schematic, which is this one up here. So we're going to hit annotate schematic. What this does is it actually applies numbers. It goes left to right. It starts numbering components. So upper left here should be R1, this one should be R2, and this one should be R3. Similarly, this will be C1, this will be D1, this will be U1. Mostly because we only have, one of most each type of components here. However, if we had 5 copies, we would have a different kind of naming system. So what we're going to do is use the default stuff here, entire schematic, keep the existing annotation, sort by X position, and then use the first free number in the schematic is fine. We're going to hit annotate. We're going to say OK. And now we can see R1, R2, C1, U1, D1, R3, just like we said. So I'm going to save once again. And now what we're going to do is we're going to actually do something called ERC, which is electrical rule checking. And we're going to do that up here. It looks like a little bug. And what we're doing is basically we're checking to make sure that things are hooked together properly. And I will say before we do this that oftentimes with the ERC, it gives errors based on the pin type. So if you remember from when we were creating this component, I said, we don't need to assign a type to each pin. So pin 7 is an input-output pin, but we didn't assign it. The default was the input, I believe. If we want to go check that, we can right-click, go to Edit Component. We can go to Edit with Library Editor, and then we can click on the actual pin itself, mouse over, hit E, and then you see this is the thing I was talking about, electrical type. It's listed as an input, but they're all listed as inputs. This may end up giving us some hassle during the ERC, but we're probably, any of those types of errors, we will ignore. All right, so let's pull that up again. Here's the ERC. We're going to hit Run. So there we go. So we select the error. Yes, it shows the errors down here where this little arrow is. Pin connected to some other pins, but no pin to drive it. So this is a similar kind of thing. It's showing that because these are all listed as inputs, the ground is expecting some kind of output pin. It's really not worth worrying about that right at the beginning. More importantly is if, say you didn't hook up a pin here, we just delete that trace. Now if we run ERC, we should see lots of errors, and we do. We see that it checks to make sure all of the pins are actually connected. That is a very critical thing that you should be checking for. All right, we can delete all the markers, close, and then undo what I just did, Control Z. Cool. We'll run this one more time just to make sure. It should just be that one error. Yep, it's just the ground error here. That's fine, and it's the same for both grounds. Okay, that's good. And now what we're going to do is hit Save. Once again, always important to hit Save. We're going to generate a netlist. And this is simply taking all of the things here, taking the connections that we've made. R1 is connected to pin 4 and pin 8. That's a netlist entry. And now we're going to generate that, and that's actually the document that gets transferred between schematic and layout. So we're in that same directory we started with. All right, now we have a netlist. Okay, and now we are at the point where we can say, yes, we're ready to go. We're ready to start doing part association. So you can see the schematic is, for small schematics, it's definitely a simple thing. It's, it's all about making sure your things are connected together and getting your parts labeled using annotation. That's very important. And then, some of the more advanced topics that you'll get into, say you took a contextual electronics, we talk about making sure you have all the information when you edit a component. So do you have the part number in there? Do you have, do you have other specifics like a voltage rating that we didn't do here? So that's kind of, it's necessary for certain things, but for our purposes right now, I think we're doing pretty good. So next up, what we're going to be doing is we're going to be associating the schematic symbols, which is what we just hooked together in the schematic, with the actual footprints. So this is going from a symbolic notation, where we show things hooked together, to the actual the physical layout of a footprint. So if you buy a chip, which pin is which, and what do those all look like, and how many pins do you need, that kind of thing. So that'll be in the next video. If you have any questions, you can go to the KiCad info forums or the YouTube comments below. Thanks for watching.